Okay, the last thing we're going to do today for 3.1 is go over these graphs of these exponential functions and some characteristics that they have. All right, so they're going to look like this. They're going to take on this form where the base will be some number, like 2, 3, maybe even a fraction raised to some variable, okay? As we start graphing them, we're going to talk about these characteristics. Naturally, the domain and range will just pop up. You don't necessarily have to memorize these. Naturally, we're always going to have a y-intercept at 1 for the parent function. If it's moved around, it might be different. Same thing with the asymptote. The parent function will always be at y equals 0. I want to write that down. Okay, even this parent function right here has an asymptote right on the x-axis. All right, so let's look at the first example. Construct the table of values for the function, sketch the graph, and then if you get a chance, verify with a graphing utility. All right, so here's our base of 2. We're raising it to the x power. So first input line, x is -2. We're going to plug it in right here. It looks like that. Then we use those exponential properties that we just reviewed. Okay, to the -2nd simplifies to 1 over 2 squared, and then we can make that 1/4. All right, so then go over to your coordinate plane, and you can plot that. Let's move on to the next one. 2 to the -1 is 1 over 2 to the first, which is 1/2. Okay, and then we can plot that. All right, plugging in 0. Anything to the 0 power is 1. So there's our y-intercepts. And then these go a little quicker. 2 to the first obviously is 2, and 2 squared is 4. So now I have all these coordinates that I can plot, okay? And so when we plot them and connect the line, we're going to have something like this. Now the y-asymptote, I strongly encourage you, the y-asymptote, the horizontal asymptote at y equals 0, strongly encourage you to draw it in there to remind yourself that this serves as like a fence. If you don't draw it in there, you might draw the graph and extend down this way. And the graph doesn't do that because the range is 0 to infinity from here up. So don't do that. You should put arrows on your graph too. Why? Because the domain's all real numbers, and that should be reflected on your graph. I know yours up here doesn't have arrows on it. You might want to, just to show that it keeps going, okay? Okay, pause if you need more time to catch up. I'm going to keep going. 2 is very similar. I'm not going to take the time to actually walk you through it. I'll just show it to you real quick. At a base of 3, and so it looks the same. It just increases a little quicker, right? 3 squared now is 9 instead of on the last problem it was 4. So exponential growth, it takes off. Okay, let's slow down though on 3 and go through this one step by step. All right, put this here just as a reminder of the property we just went over. We have a fraction raised to a power, or we raise the numerator and denominator. That's going to happen on this first line. So when I take -2 and plug it in, I want to raise the numerator to that -2nd power and the denominator to that -2nd power. Okay, and they got to flip spots, right? The 2 to the -2nd goes to the numerator. This goes to the denominator. So it's 4. So we plot -2, 4. I already have no graph here, but go to -2, 4. Make a coordinate. Okay, I want you to finish the rest. Why don't you do the rest of the table and then check back in about a minute or two and see how you did. All right, here's your feedback. Here's the table. Plot all these coordinates. And now we have what's called an exponential decay model. All right, from left to right. This is slowing down and decreasing. Okay, still have an asymptote of y equals 0. Looks like that. Okay, we'll continue on tomorrow on the next video. Stopping there today.